Now let us see what is calculus. Calculus is another part of mathematics. Now most of our syllabus will be related to this calculus, and this is an operation on functions which you studied in the second chapter. 11th also, 12th also you will learn. 12th also you will learn also. Those who are in 11th they will learn in 12th. Those who are already in 11th they learned what is a function. Now this calculus is divided into two parts. One is called the differential calculus and the other is called the integral calculus. Both of them are one type of operation in functions, and one is the reverse process of other. So what type of operation is that, how to operate, that all you will study in coming classes. Now in a function we studied what is meant by domain and what is range. For example, f of x equal to x plus 1 upon x minus 1. What are the possible values I can keep for x so that this f of x is a finite result? That is what is called domain. So you know that if I am putting x is equal to 1, denominator becomes 0. So I cannot use x is equal to 1. Other than x is equal to 1, we may keep any value for x. You will get a finite result that we studied. So the domain we are saying r minus z1. So if we are simplifying and getting a range means after putting the value of x, we will get a corresponding result. That set of result is called a range. The results which you can obtain from a function after keeping a particular value for x, that is called a range. In this case, domain and range will come same, not necessarily in all the cases. Now here we note that I cannot put x is equal to 1. Now what we are going to see, what will happen when I am putting a value which is very near to 1. We know that real numbers, rational, every number is a real number. So x is equal to 1 and the values which are very near to 1. For example, x is equal to 0.9999 etc. It's a number very near to 1. And here also x is equal to 1.0001, which is also a number very near to 1. Now, how we can use these values in this function? That method is called limit of a function. The word limit. Here we are not using the value for x is equal to 1 in this case. We are going to use the values of x which are very near to 1. That is what is called x tends to 1, or it is reading as x approaching to 1. X is very near to 1. What the difference between x is equal to 1 and x tends to 1 is, x is equal to 1 means only one value of x, but x tends to 1 or x approaching to 1 means x can be x can take an infinite number of values which are very near to 1, or we are saying the values of x are neighborhood of 1, neighborhood, very near to 1. So here x can be an infinite value, 0.999, I may keep any number of 9s, never will be equal to 1. Similarly, I may put 1 point any number of zeros and after that a 1, that is also not equal to 1. Then what happens if I am using x as a number very near to 1? X is equal to 1 not defined, but when I am keeping a value x, value of x which is very near to 1, what is happening or how to evaluate? That is called a limit. Now how to represent it is, the short form of limit is LIM, limit. x tends to 1. Just below that we will write limit x tends to 1 f of x. Here f of x I took as x plus 1 upon x minus 1. Any values you can give. I just took an example. So limit x tends to 1 x plus 1 upon x minus 1. I may keep any value of x which are very near to 1. So x cannot be equal to 1, tends to means not equal to 1, but very near to 1. I may keep any value of x which are very near to 1. The result remains not defined only. Why? That we are going to study in the coming cases. Which of the cases I can get a finite result for this, and which of the cases I may get a not defined value for this. Not defined means no such values exist. That's the meaning of not defined. Now there are 3-4 methods of evaluating limit. One of the method is direct method. In direct method we will put x is equal to 3 directly in the function. Only when the denominator of the function is not 0. Here I am putting x is equal to 3, denominator will not be 0. So I will keep x is equal to 3 in the both numerator and denominator. I will get 14 by 5. Why we are keeping, I am giving a simple example here why we are applying direct method. Suppose limit x tends to 1 x plus 1. This is equal to, suppose I am writing x are 0.999999 plus etc. plus 1. That will come 1.999999 etc. This is approximately equal to 2. That is why we are putting directly. But if the denominator is 0, then we cannot put directly that one. Now, second method is called factorization or rationalization. If direct method fails, in case denominator is coming 0, when you are putting the value of x directly in the function, then we will use factorization or rationalization. For example, this one. If I am putting directly x is equal to a denominator is 0, so I factorize the numerator and denominator so that x minus 1 can be eliminated. It can be eliminated because x is equal to 1 is not possible, tends to means not equal to. So it is very near. So I can cut x minus 1 and x minus 1. Now I may put directly x is equal to 1 because denominator 0's problem is gone. Now I put x is equal to 1, so I got the 2. So in factorization, what we will do? We factorize the numerator or denominator or both, so that the part which make problem in the denominator or which make the factor which make 0 in the denominator, if eliminating, then we may apply direct method. If not eliminating, then direct method fails. Then the second method is, another method is rationalization. In 9th standard you studied how to rationalize. Here numerator I rationalize, you may rationalize the numerator or denominator. Here also same problem, x is 0, this x must be eliminated. So after rationalization we know numerator root will go at the opposite side multiplied. So simplifying, here x get eliminated, then I apply direct method, x is equal to 0 if I am putting, numerator will come 2, denominator also will come, root 1 is 1, 1 plus 1 2, 2 upon 2, answer is 1. That's the second method. We will see more problems after this. Then the third method is called the formula method. There are few formulas in limits. One is limit x tends to a x raised to n minus a raised to n upon x minus a is equal to n into a raised to n minus 1. Here you see x raised to a number, same number is written on a, and you see that the difference between these two is in the denominator, x minus a, and both of the numbers contains a same power. Then the result is this n into this a raised to n minus 1. Example here, x minus 2 is here and both x and 2 having 5 as the power. So the result is 5 into 2 raised to 5 minus 1, that is 5 into 2 raised to 4, that is equal to 80. That is one of the formula. Second formula, two formulas in trigonometry are there. Direct method fails, but you will get the result for it. Sin x upon x and tan x upon x. both will be 1 only when limit is extending to 0. This limit is possible, means this result is 1. You have to see in the 3 places 1 what is the value of x extends to 0 or not, and the same x is written here or not, and same is x is written here. 3 places same number must be there, x extends to 0, then only the result is 1. Here this presently it is not a 1 because here 3x but here x. So what I multiply 3 here, multiply in the numerator and denominator. So this problem gone now. So 3x. Now as x is tending to 0, if you are multiplying here 3 both sides, so 3x also tends to 0. So all the problems eliminated. So this part is going 1. So the result is 1 into 3. Similarly, the next result is for e raised to x. Limits here also 3 parts you will see, x tends to 0, e power, and the same minus 1, this format, this is a format, that is 1. An example is written here, 3x, so denominator also 3x required, so 3 multiplied divided, so x tends to 0, 3x also tends to 0 as in the numerator, so this result will come 3. And finally one more is that here also 3 part you will see, limit x tends to 0 log of 1 plus x upon x, here also 3 part, 1 plus whatever is written, that is in the denominator and that tends to 0, then only the result is coming 1. We will see more results on this now. So let us see some examples. So some questions on limit are there. I want to find out the limits existing or not. Here limit x tends to 2, x raised to 5, 2 raised to 5. That name is there, but to make it a formula, I need to divide by x minus 2 in the numerator also, denominator also. So I divided x minus 2 in the numerator and denominator. So numerator is also forming a formula, denominator is also a formula. 5 into 2 raised to 4 and 10 into 2 raised to 8, simplifying 1 upon 32 is the formula for the z. So here actually we applied the formula as limit x tends to a, x raised to n minus a raised to n upon x minus a we apply is equal to n a raised to n minus 1. That's identity we applied there. Now here factorize the numerator, x plus 3 get cancelled, so it will come 3 by 2. Here denominator rationalized, simplifying we get 2. Here LCM separated to make it 1, sin 2x multiply divide, since x tends to 0, 2x also tends to 0. So this is 1 into 2 plus 0 is 1, 0 is 1. So answer is 3. So here we applied limit x tends to 0, sin x upon x is equal to 1. That formula identity applied. Here numerator and denominator both rationalized, simplifying. Here after simplification, numerator 7 minus x, denominator x minus 7, so cancelling minus 1. Now put the value of x is equal to 7, you will get minus 1 by 4. Then here numerator and denominator factorize, x minus 4 get cancelled. Remaining x minus 3 upon x plus 3, now you put x is equal to 4, you will get 1 by 5. Here 1 minus cos mx formula is applied, 2 sin square 3x by 2 upon x square. Now it is separated into 2 format, and to make it 1, sin 3x by 2 multiplied and divided so that it will become 1. The same is written here, square I is split it into 2 and I made it into 1 so that 2 into 9 by 4, 9 by 2 remains. And similarly last question, to make the e raised to x format 1, I divide and multiply by an x, so x square is there, and apply 1 minus cos x formula as 2 sin square x by 2, I wrote it as 2 times. Now here also I made it into 1 x by 2 multiplied, divided, so x square by 4 multiplied. So the numerator is already 1, and this x square and this x square cancel, the remaining x is equal to 1 to 0 you put it, means here nothing, x is equal to 0, there only identities are there, 2 identity, 1, 2, here also an identity, here also an identity, simplifying 1 numerator upon 2 into 1 by 4 will come 2 as the result.
Now what is left hand limit and right hand limit? Now as I told in the starting part, x tends to 2, suppose a number. So actually on the number line 2 is here, the left side 1 is there and right side 3 is there. X approaching to 2 means x may approach from left side of 2 or right side of 2, means 1.99999 etc. it may reach to 2, and similarly 2.00001 may etc. reach to 2. So left side also x may approach, right side also x may approach, means in the neighborhood of 2 there are numbers which are less than 2, example 1.999 etc. There are numbers more than 2, that is 2.0001 etc. So which one to be used, that we are using in left hand limit and right hand limit. Now consider a function a, here I took it as 2. There is a formula to find out left hand limit. This is the formula, limit extends to a minus. This minus shows that the left side of a is considered, where that x value will be a minus a very small number, a minus h is tends to 0. H is a very small number, means if you are subtracting a very small number from 2, you will get the left hand side of 2. 2 minus a very small number, 1.99 etc. So the left side of the numbers can be obtained by subtracting a very small number, and to get the right side of the right side of the neighborhood you can obtain by adding a very small number. That is RHL, limit extends to a plus. Plus shows that right side, minus shows that left side f of x. Here x is a, the number to be added is a very small number. Here also 2 point a very small number, 2 plus a very small number is 2.0001 etc. Now which are the situation you required LHL and RHL? LHL and RHL are not always required. If a function contains more than one definition, one example I took, use this modulus x plus 3 for x less than or equal to minus 3, minus 3 are less than or equal to minus 3, any number use this one. In between minus 3 and 3, in between minus 3 and 3 use minus 2x, and more than 3 use 6x plus 2. For example, if you want to find out f of minus 4 or f of minus 5, you use this function. If you want a number f of 1, f of 0, f of 2 like that, you use this function. And if you want a number more than 3, means 3 or 4, 5 etc., you have to use this. Now suppose I want to find out limit extends to minus 2. Minus 2 is coming exactly in this. So I use the minus 2 directly in the function. Here I use, because there is no denominator, so it is coming 5. Similarly, extends to 2 is coming in between. So I used as minus 2 directly here. Sorry, x2 directly here. So minus 2 into 2, that is minus 4. Similarly, last part I use 5, so 13. But the problem is arising when you are going to find out minus 3, tends to minus 3. This minus 3 is written here also, minus 3 is written here also. The left side of minus 3 is here, but the right side of minus 3 is in another part. So such cases you are required LHL and RHL. So means at a particular point, two functions are coming at the same time, then you are required LHL and RHL. For example, I want to find out limit extends to minus 3. We need LHL and RHL. So I used LHL, limit extends to minus 3 minus, here A as minus 3. This minus shows that left side of minus 3. So left side of minus 3 is this. So I changed x as minus 3 minus h, as I told you, a minus h. Here a is minus 3. So minus 3 minus h. I put h is equal to 0. So modulus minus 3 plus 3, that is equal to 6.
Now RHL equal to limit x tends to minus 3 plus minus 2x means the right side of minus 3, right side of minus 3 is here. So here also x I changed it to minus 3 plus h in the RHL part. A as minus 3, so minus 3 plus h. So h is 0, so minus 2 minus 3 6. Both LHL and RHL same result. So the limit also same. If LHL and RHL same, then the value of the limit also same. If LHL or RHL are not defined, well are not same, then the limit also does not exist. Now here also you may see whether here it is coming directly, you put minus 3 here, it is coming 6, here also you put 6 itself is coming. So you can say LHL equal to RHL. You can verify your answer is correct or not. But the method of showing is like this. You can verify directly by putting here. Now let's see 3. 3 also the same trouble is there. Left side of 3 here, right side of 3 here. I put directly. So here it is coming minus 6, but here it is coming 20. So LHL and RHL are different. Limit x tends to 3 does not exist. That I was shown here. Limit x tends to 3. LHL I started. Limit x tends to 3 minus 2x because left side of 3 is minus 2x. I converted to 3 minus h because a minus h is equal to 3. 3 minus h, simplifying h is 0, you will get minus 6. Similarly, RHL equal to limit x tends to 3 plus. So h I converted into 3 plus h, put h is equal to 0, 20. LHL and RHL are different, so we will say limit x tends to 3 does not exist. So here one important note, LHL and RHL are required only when a function having more than one definition at a point. More than one definition at a point. You see minus 3, there are 2 definitions. Here 3, there are 2 definitions. Then only you need LHL and RHL. If LHL and RHL are same, then only limit exists. If LHL and RHL are not same, then limit does not exist. So let us see some more examples. Suppose you want to find out limit x tends to 1, greatest in the function x not exists, because tends to 1 means left side of 1 will come 0.999 and etc. The greatest in the part, in their part you are taking 0. Similarly, RHL will become right side of 1, 1.000 etc. The result is 1. LHL not equal to RHL, so limit does not exist. But any fraction if you are taking other than integer, any fraction you are taking, then limit will exist. LHL and RHL will be same. That you may check it any fraction. For example, 3 by 2, left side of 3 by 2 also 1, right side of 3 by 2 also 1. You can check it. Now similarly, modulus x if you are checking, it will become 0 only, limit exists. But with LHL RHL you can take same result, but signum function not exists because left side of 0 you know minus 1 and right side of 0 you know 1. LHL is minus 1, RHL is 1. So such functions does not have limits. So what is the application of limit is to find the slope of the tangent at a point. At a point, how can you find out the slope? That is the application of limit. Here I took y is equal to f of x, the graph. Y is always f of x. So I took x comma y, actually f of x, and I find out a very near number by adding a small number to x. So when I am putting x as x plus h, here also will come x plus h. We studied what is the slope y2 minus y1 upon x2 minus x1. Here you apply limit, you will get as h tends to 0, you will get this secant actually tangent. If you are putting this h tends to 0 as h tends to 0, so you will get the slope of the tangent through p. So slope of the tangent at p, it is also called a derivative at p. Slope of the tangent is actually called a derivative. The formula is here you apply limit h tends to 0, f of x plus h minus f of x upon h. So it is denoted by derivative at a point p of a function f of x is called f dash x or dy by dx,
or slope of the tangent at P. Slope of the tangent of a function at a point P is called f dash x or dy by dx. Now, so what is the formula to find out? This is actually the formula. F dash x is same as limit h tends to 0 f of x plus h minus f of x upon h. It is also same as dy by dx. Such a method of finding limit is called first principle. One example is use sin x. If you are using first principle method, f dash is equal to limit h tends to 0 f of x plus h. X change as x plus h, sin of x plus h minus f of x. F of x is sin x upon h. Sin c minus sin d formula applied. Denominator h I wrote here so that I made it into 1. So simplifying, we will get cos x. We will say the derivative of sin x at a point P, slope, derivative. That means slope of the tangent at a point P of the graph of sin x. The result will be equal to cos x. So in short, I can say d by dx of sin x is derivative of sin x is cos x. Similarly, if same formula applying with the cos x, I will get minus sin x, tan x I will get sec square x, cot x I will get minus cosec square x, etc. Now let us see the formulas of derivatives. Formula sin x is cos x, already we studied. Cos x derivative is minus sin x. Tan x derivative sec square x, cot x minus cosec square x. This all you can derive with help of first principle. Sec x tan x, cosec x minus cosec x, cot x. In trigonometry you see complementary functions, complementary t functions having the result always negative. Cos, cot, cosec, all the result will be negative. E raised to x, log x 1 by x. The base of log x is e, keep it in mind. The base cannot be any other number. The base of log x is e, no base is written. X raised to n, x raised to n minus 1. This power will come out and the power will be reduced. A raised to x is a raised to x itself. Here you see e is an irrational number, approximately 2.7. But any number other than e, the result will be a raised to x into log a. Now chain rule, the method of finding derivative with the help of these formulas. You have to by heart these formulas, so that by using these formulas we can find out the derivative of any function. That is what is called the chain rule. X raised to 10 means 10x raised to 9, as I told here in this formula. Now into x derivatives, the x derivative also multiplied by 1. Here the importance you see, here also x, here also x. Here both the variables are same. Here also like that. X. Any other variable is coming, then it is not possible to do by this procedure. So 5x raised to 3. So 3 into 5x the whole square into 5x derivative, that is 5 into x derivative 1. So into 5. Then sine of cos 2x. First we'll write the derivative of sine derivative cos, remaining things same. So we wrote a derivative of sine multiplied by cos derivative. Cos derivative is minus sine, 2x you wrote like that, then followed by 2x. There are three functions. First one sine, then cos, then 2x. We will write the derivative of all function. When you are writing the derivative of one of the function, the remaining part remains same. Sine derivative is cos, so remaining part remaining same. Now sine is gone, sine derivative is written. Next we see cos derivative is minus sine, so 2x you wrote like that. Then cos is also gone, 2x derivative is into 2. Similarly tan cube, first I wrote the power will come outside, then the remaining thing same. You see 10x raised to 9. 10 outside, same thing, 1 reduced. So 3 outside, here 1 reduced, remaining thing same. So 3 is written, then I wrote the derivative of tan. Tan derivative is sec square, e raised to x. Tan derivative is sec square, e raised to x. Then e raised to x derivative multiply. Similarly, cos square 5x. 2 cos 2 reduced by 1, then 1 is there. Then cos derivative minus sine, here minus will come, minus sine into 5x derivative 5. There are some properties. Derivative of a constant is 0. How can you identify a variable or not? Only two variables are there in dy by dx. One is y and other is x. Any other thing is coming, then always consider as constant 0. D by dx of 5 0. Then constant and function together, then constant we write like that. For example, 5 cos x, again variable is also there. 5 into minus sin x, so minus 5 sin x. If constant alone, then only 0. Any other variable is there, then never will be 0. Sum or difference of two functions, so separately you differentiate. For example, x raised to 5 plus 2x square minus 1. We'll write the derivative of x raised to 5 as 5x raised to 4 plus 2 into 2, 4. 4x minus 1 derivative is 0. Two more properties. One is called the product rule. Derivative of product of two functions. Two functions product. Functions means two functions in terms of x. One is sin x and other is cos x. 5 and sin x are not a two function. 5 is a constant and other is sin x. They are not two functions. So how to find out such a case of derivative? Never we can find out both of the derivative together. We will write one of the function as such and write the derivative of the second plus second function as such and the derivative of the first. Means at a time we will write the derivative only one function. One function you write like that, then write the derivative of the second plus second function you write like that, then derivative of the first. That is written f of x into g dash x. G dash x means derivative of g of x plus g of x into f dash x. F dash x means derivative of f of x. One example, x square and e raised to 5x. You see here also x square, x, two places x are there and product is there. So you cannot write the derivative together. X square I wrote like that. Then we will write the derivative of e raised to 5x plus e raised to 5x I wrote like that into derivative of x square. One function like that, then the derivative. Whenever you are writing the derivative, apply chain. You see, x square into e raised to 5x derivative is e raised to 5x into 5. How came this 5 chain rule apply? Plus e raised to 5x into x square derivative is 2x. That is the product rule. Then another rule is the quotient rule. Similarly, numerator and denominator both contain functions. Then always we start from the denominator. Denominator you write like that. Write the derivative of numerator minus numerator you write like that. Write the derivative of denominator divided by denominator square. Denominator derivative square, not denominator square. So that is written g of x into f dash x. F dash x means derivative of f of x. G of x into f dash x minus f of x into this f of x into g dash x divided by g of x whole square. F dash x and g dash x are the derivative of f of x and g of x respectively. One example here, numerator and denominator both contains derivative. Denominator into denominator wrote like that into derivative of numerator minus numerator we wrote like that into derivative of denominator divided by denominator square. Simplifying, 1 plus x square into 5 raised to x derivative is 5 raised to x into log 5. That is a formula to tell the formula you see that is written there. A raised to x derivative is a raised to x into log a. Minus 5 raised to x wrote like that. 1 plus x square derivative is 2x because 1 is a constant, derivative is 0, alone written to 0. X square derivative is 2x divided by 1 plus x the whole 1 plus x square the whole square. Now there are two important results. If you are learning, then the questions you can do very easily. Suppose 1 upon x contains a power. Only x contains a power, then nx raised to n minus 1. But here denominator contains a power. Then the denominator multiplying the numerator, change the sign and increase the power. Denominator you multiply the numerator, change the sign of the numerator and increase 1 power. See 1 by x. The power is 1. 1 into 1, change the sign divided by increase the power. Similarly for 7 into 5, 35, change the sign divided by increase the power and so on. Directly you can apply, no need to go any other format. Similarly root x also, root 1 upon 2 root x. Root x derivative, if we are going for x raised to n formula, same result, but the root terms you can directly 1 upon 2 root. For example, root sin x. 1 upon 2 root sin x, that is root derivative into sin derivative cos x. We can apply chain rule like that. E raised to root x, e raised to root x, e raised to root x itself into root x derivative is 1 upon 2 root x. And two questions are there, e raised to x into tan root x equal to e raised to x into this product will be applied here also, here product rule applied and here quotient rule applied.